title of this section is A Step into the Third Dimension. We're going to talk about some of the 3D technologies that are available right now, and then I'm going to briefly describe Stonex 3D sensors and Stonex 3D software. Technology is improving fast, and as it's happening in all the aspects of our lives, the 3D scenario is changing as well. Instruments and dedicated software are getting cheaper, and dimensions of the sensor are getting smaller. This means that they are way more accessible than they were before. There are few applications that are speeding up the process of the 3D digitalization of the objects and of the building, and BIM is definitely one of them. Here are a few of the many 3D technologies available. The Terrestrial laser scanner allows you to quickly survey an area with high precision. In a few minutes, you have a 3D model with many attributes like reflectance, inclination of the walls, and the color as well, thanks to the picture. It has many fields of application, but above all, it helps you when you need to survey an irregular structure. So they are usually hard to survey a model with other instruments. As you can see in this video, for example, this is a complex area to survey, but with a laser scanner, it was possible to get an accurate model of the church thanks to a very dense point cloud. Another common application of the laser scanner is the as-built survey that is useful to monitor the work progress of the site, and as we can see in this video, to confront the actual physical work with the 3D CAD model. This is a process that shows us in a super accurate way the differences between how the work was supposed to be done and how it actually is. Differences can be caused by human error while building the structure, or even structural interferences that have not been calculated. Another field of application is volume calculation that can be done in different environments, like, for example, this pile of rubble that has to be moved, so volume calculation is pretty useful when you need to do something like this. So another 3D technology is the photogrammetry. There are two main branches of photogrammetry, the aerial photogrammetry and terrestrial and close-range photogrammetry. Let's start with the last one. What you can see in this video is an example of close-range photogrammetry. With photogrammetry, you have to pass several well-defined stages in order to generate a 3D digital model of an object. You need to take many pictures of it, and it is necessary to have a good overlapping between them. With the help of a specific software like this one, you can get high quality point cloud from the pictures you've taken. And it's a pretty dense point cloud as well. What is the most interesting about 3D technology is the possibility of combining two or more techniques, because they all use a common language that is called point cloud. Here you can see a point cloud created with a terrestrial laser scanner, and that has been integrated with a more detailed point cloud that was made with the close-range photography technique. It's the same example we saw before, we just saw. So the integration of the two makes our work way easier, because we don't need to do everything as precise as this close-range photogrammetry is. Aerial photogrammetry is the taking of the photographs from an aircraft or another flying object in order to model a territory or an object in 3D dimension. Through the past years, UAVs became something extremely common in our life. Drones are being developed in many countries around the world, and this means that they are way more accessible than they were before. Drones can be used for many applications like filmmaking, scientific research, agriculture, and many more. Photogrammetry is, of course, among them. What we need to pay attention is, when we do aerial photogrammetry, is a good overlapping between the photos that can be set directly on the flight planner software. To get more accurate point cloud, it is important to have measured coordinates of set point that are called control ground points. That will help the software to elaborate data better. Taking pictures and photographs from a flying object allows us to cover vast areas in a short period of time. To survey parts that would not have been possible to measure with other instruments. Here, for example, is an example of only half an hour flight of an area that couldn't be covered using something else that it was not photogrammetry. As we have seen before, what's interesting is the opportunity to work with point clouds created from different sensors. Here is the same example that we just saw through photogrammetry, integrated with a 3D laser scanner point cloud. So the vertical part is more precise, and it was made with the TLS, and the contrast and the color of the point cloud was created with photogrammetry. As you can see in this video, we put some contour ground points in order to get the better quality result of the point cloud. So drones can be used with photogrammetry, but can be equipped with LIDAR as sensor as well. They have to be big drones that can take the extra weight of the sensor, and for this reason they are a little more expensive, but they definitely have a lot of pros. The main pro is that LIDAR measures directly the distances illuminated the area with a scanner, and measuring the reflection of the sensor. For this reason, it's easier to get accurate infos from more difficult areas in a shorter amount of time. LIDAR sensors help us a lot with some application. For example, when there's vegetation involved. For its technology itself, it's easier to get infos through the trees and branches, and for this reason is also easier to define, for example, the ground level. You see the trees that were before have been cancelled and they've been deleted, and this is the DEM of the ground below the trees. LIDAR sensors can be mounted on different supports, and here is an example of a backpack. It's easy to use and it allows you to scan anything that surrounds you while you're walking. And it does not have a specific origin because it keeps moving with you, so it's a little less accurate than a terrestrial laser scanner, but it is an extremely versatile tool for field operation. Its weight is low and it allows you to operate in absolute autonomy. As you can see here, you get a lot of data, and even the trees are not a problem because you're scanning while moving, and you get a complete 3D model of what you're walking by. Handheld scanners are part of the 3D technology family. The biggest feature of this instrument is the portability. They are small and light, and they can be carried easily. The more you move around the object you want to scan, the better the result is going to be. Here is an example of a man taking a scan with the handheld scanner, and on the right you can see a real-time reconstruction of the acquired data that you can see directly from the tablet you're holding, like this one is doing. So this is the result of the scan we just saw. After some process of this point cloud, you can get an accurate 3D model that is 1:1 scaled. And scanners like these are often used for cultural heritage and archaeology, because you can easily digitalize small objects that cannot be moved. For example, if they are in a museum, you don't have to move them, you just walk around them and you create a 3D model out of it. What we're watching right now, it's not a video, it's a 3D model of a room. This means that I can take the measures and it has attributes like the colors, for example. This was taken to keep track of the position of the wiring before laying the screed. A scan like this one is extremely useful when you need to do some maintenance work, because you know exactly where you're going to find and you know what to avoid and what it's better to do in order to fix the problem. So all the data sets we just saw were made and processed with our software and products or our partners. Now I'm going to briefly describe them, sensor and software as well. That will be better explained in dedicated presentation as well. Here is our 3D terrestrial scanner, X300. It is designed to deliver effective results. It's easy to use, reliable and flexible. The X300 rapidly determines high resolution measurements with very short time. It has a 360 degree of field view horizontally and 90 degree of field view vertically. Its fully sealed case allows you to get the job done in even difficult environments, and it is super user friendly. It can be controlled with a smartphone or a tablet with just few buttons and clicks. And it comes with a complete set of accessories that provide flexibility, the flexibility I was talking about. Right, for example, the GPS kit that is designed to connect the GNSS receiver to the X300 to get the scans that are already georeferenced. Or the framework that expands the field of view of the scanner and allows us to scan the ceilings or tunnels. As you can see, it's a 240 degrees field of view. X800 is our new all-purpose laser scanner. It is a full dome scanner with a 270 field of view. It collects 1 million points per second with multi-echoes scan, and it has a maximum range of 800 meters. F6 is our handheld laser scanner. It works with active triangulation, and thanks to the infrared light combined to an RGB camera, you can collect high quality data in places that are hard to reach or even under difficult lighting conditions, because IR light works also when when the environment surrounding is extremely dark. It has a working range from 50 centimeters up to 4 meters and is extremely user friendly. It only has one button that controls all the operations. Here comes the first of our software, and it's called Reconstructor, and is a software to combine 3D information from different sensors, elaborate the data sets, and export informations as well. The main advantage is the independency from a specific sensor and the comprehensive amount of tools and features that allow you to an easy extraction of quality result in many fields like mining, surveying, forensics, BIM, and so on. It has 4 different modules that can expand the set of tools that you can use on the software. Survey is a basic model, and it has all the cloud management tools in it. You can register the point cloud, edit them, and of course export the point cloud in many formats, from the common E57 to, for example, the LAS or PTX. Color mapping will allow you to use your own high-resolution camera to color the scans in order to have the best quality colors for your meshes and point cloud. And the construction model gives you many advanced features for BAM, BIM, or architecture and construction. Is the same model we saw with the example of the BIM work I showed you before. Mining will allow you to have all the tools you need to work with quarries, cut and fill volumes, excavations, and DTMs. CubeScan is another 3D software that you can use to work with point clouds, and it's part of the Stonex Cube suite. It allows you to combine 3D models from different sensors and extract information. It is possible to import the software point clouds in the most common formats like E57, LAS, PTX, and of course the point clouds coming from the Stonex X300 laser scanner. CubeScan allows you to filter the point clouds, and their integration can be done using a variety of registration tools that helps you a lot with the data process. It is possible to extract point information, measures, or to generate section order photos and edges that you can export and use in your own software. Here, for example, is an example of the automatic edge extraction tool that will extract the edges of the point cloud automatically, and they can be directly exported in the XF format. Zephyr is a photogrammetry software that allows you to reconstruct also 3D models, but from pictures and not from data from the scanner. The process is entirely automatic. There are no coded targets, manual editing, or special equipment are needed. As you can see from the screenshot here, it comes with a user-friendly interface, and it also gives you the possibility to export in many 3D formats. It also has a lot of advanced functionalities, and for example, once you have created your 3D models, you can edit them, create through orthophotos, calculate areas, volumes, angles, contour lines, and much more. Stonex CubeFly allows you to perform advanced UAV drones missions planning and to process photogrammetry calculation of digital images. Choosing one of the camera's presets and selecting the areas of the mission, the software will automatically calculate the path and the infos about the flight, such as speed, total time, number of shots. Once you have finished your mission, you import the pictures you've taken with the drone, and you import the GNSS and TS survey to use as control ground points. And still, with the help from the software, you process the pictures in order to obtain a 3D point cloud, meshes, orthophotos, so you will have a 3D model of what you surveyed. So the aim of this presentation was to show you some of the many 3D technologies that are available right now. As we said before, it's the most important thing about these technologies is the possibility to combine two or more techniques because they all use the common language of the point cloud. Here is a diagram that shows you how our sensors and software are integrated and work together thanks again to the point cloud. Thank you.